Okay, we have been working with linear inequalities. I kind of explained on the previous video about the key rules that you just basically need to think on these stuffs as if they were linear equations. With the only rule, like there's an exception here that when you pass to divide negatives or to multiply, you're gonna have to flip the inequality symbol. We haven't done this yet, but we're gonna do it in this video. Okay. The last exercise we did was just kind of like an introduction on how to do these things. Okay. Now, in this case, I got an open bracket, okay, or an open answer, we could say, for the initial number, but that doesn't happen all of the time. Okay. So let's focus now on this other exercise. Okay. I have the exercise that says 4y minus 3 is greater than or equal to 7y minus 9. And yes, you read this thing as greater than or equal to, because there's a mark. If you can see, there's a mark under the greater than. Okay, it's not like in the previous one that you just have the symbol that is called greater than. You have greater than, but you also have a mark that kind of like seems like an equal, like with the line that's under the greater symbol. It looks like an equal, so we call it greater than or equal to. Okay, so let's solve this thing as if we were solving a linear equation. So we move the letters to the left and we move the numbers to the right. So it will be 4y minus 7y, okay, greater than or equal to minus 9 plus 3. So 4 minus 7y would be negative 3y. Negative 3y is greater than or equal to negative 6, because minus 9 plus 3 is 6. The signs are different, so you need to subtract and you copy the symbol, like the sign of the greatest amount, which is in this case 9, so I'm going to copy negative. Now, in this case, if you notice, the next step is I'm going to send negative 3 to divide to the other side. But because it's negative, if you remember, there's a box in here that says if you pass a negative to divide, the inequality sign will flip. And I also tell you here this: if you pass a negative to divide, flip the inequality symbol. So you have to do that when you pass a negative to divide, because the 3 is negative. Once I pass it to divide, I'm gonna flip the sign. Do not do it on the previous step. No, do it until you pass it to divide. So in here I'm gonna put y, and instead of greater than, I'm gonna put less than or equal to negative 6 divided by negative 3. Do you see that I flipped the sign? It's no longer pointing out to the right. It's no longer an arrow to the right side, but now it's an arrow to the left side. Okay, so I basically flipped it. When you pass to divide a negative, you flip the sign. Okay, as simple as that. So I will put y is less than or equal to minus 6 divided by minus 3 would be minus and minus plus 6 divided by 3, 2. So my answer will be y is less than or equal to number 2. That will be the first answer, the algebraic notation of the solution. Now I'm going to have to look for the other notations of the same solution. Okay, the graphic notation. If you notice, this arrow is pointing out to the left, so I'm going to make a drawing that is basically going to the left side, not like in this one that it was to the right side. It's going to be like in the opposite direction. Okay, so already have in here like the drawing so that you can see it. Okay, so I start on number 2 because that's the number of the answer. Okay, and because this is pointing out to the left, I'm gonna color to the left. Now, do you notice that in this case the little ball in here is colored and it's not like the white ball from the previous exercise? That's because this less than has this mark of the equal. Okay, the equal mark is forcing me to color that circle. If you don't see the mark, you're not gonna color, you're gonna leave it as a white circle. But if you see that line, that extra mark in there, okay, and I mean the extra mark, I mean this line that's in here, okay, not only the symbol less than, but also that line. If you see it in there, you're gonna have to put a circle that is colored. Okay, so I'm gonna color the circle on 2, and I'm gonna paint this area, and I'm gonna put an arrow to explain that this goes forever. Okay, so that will be my graphic notation for the solution. Okay, so now let's do the next one, the interval notation of the solution. Okay, remember interval works with brackets, and here is where it's kind of like interesting. If you see the line, always read the drawing. Okay, focus on the drawing, always read the drawing from left to right. So the starting point of the left of the drawing on the left, it's not that clear because it's basically an arrow that it gives you an arrow that goes forever on the left. So if I go forever on the left, remember that I told you that forever on the left is negative infinity. So the beginning of the drawing is negative infinity, and the end of the drawing is 2. So I'm gonna begin on negative infinity. And remember, we always put the infinities open, so this bracket is gonna be with the antennas outside. Okay, so open minus infinity. Okay, so from minus infinity until number 2, because that's where the drawing stops, because there is nothing colored on the right side, right? So we stop on number 2, yes. But if you notice, the number 2 is colored. Okay, it's not a white circle like in this one. So because it's colored, we're gonna close the interval. Okay, so a colored circle is gonna mean closed, and a white circle is gonna mean open. Okay, so because this circle is closed, we're gonna close the interval. Okay, so if you know this, okay, in this interval, it's open on the left side, but it's closed on the right side. Remember that, like I told you, remember that closed will be this, okay, and open will be the opposite way. But sometimes you can mix things, like you could close on the left and open on the right, or you could open on the left and close on the right. It depends on basically which drawing you get. Okay, depends on your answer. But yeah, because it's colored, that means we're gonna close that thing, and that's the solution in interval notation. Okay, now for set builder notation, remember that we need to put the curly brackets, and we need to put x such that x belongs to R, comma, and okay, wait a minute, I kind of made a mistake in here. Okay, if you notice, the variable of the exercise is letter y, right? So I'm not gonna use x, I'm gonna use letter y. Okay, so it's y such that y belongs to R, and y is less than, or equal to number 2. Okay, once you do that, you close the braces, okay, the curly brackets, and that will be it. Okay, that will be the process for this thing.